In this video on our series of software development, we return to testing and have a look at different types of test data. The type of test data we use during testing is really important. When performing ongoing unit testing, module testing, and subsystem testing, we should select a range of test data to cover normal data, boundary data, and erroneous data. So what do we mean by these types of test data? Well, normal data, or typical data, is data that should be accepted by the program without causing errors. Boundary data is data of the correct type that is on either edge of the accepted validation limits. And erroneous data is data that should be rejected by the program. Let's look at a range of suitable test data for a simple program written in Python. Okay, so on the left here, we have a number of tests, and we have the type of test, the input, and the expected output. We can see here what our little program is. It prints to the screen 3 options: new game, save game, and play game, numbered 1, 2, and 3. We then set a choice variable to be 0, so that's a variable being initialized. And we say while the choice is less than 1 or the choice is greater than 3, we'll keep prompting for them to enter a choice. So the only valid options here are 1, 2, and 3. So anything less than or greater than that, we want to keep saying enter a choice. Well, we should always check for no data. So you should always check the special case of no data being entered at all. This isn't strictly erroneous data, but it certainly isn't what you'd want the user to do in most cases, and we should check our program handles that. Here's an example of erroneous or invalid data, data that should be rejected by the program and not cause the program to crash. So we're expecting a number, 1, 2, or 3. Well, what happens if they enter a character, or a negative number, a fractional number, or simply a number outside of their range? That's a range of erroneous data, and we should check for all of those. We then have what we call normal data. So this is data that should be accepted by the program without causing an error. So here we're choosing 2. That should be accepted and the program should work. We then have boundary, extreme, or edge data. Data of the correct type that is on either edge of the accepted validation limits. Now, the inputs 1 and 3 could also be considered normal data in this scenario, but we're better off referring to these special cases as boundary data. The inputs 0 and 4 could also be considered erroneous data in this scenario, but again, we're better off referring to these special cases as boundary. These are the values that sit either side of the limits of what is acceptable and what is not, and it's really important we test those boundaries. So let's look at a scenario here. What data could be used for this car ticket machine software? Well, we've got a lot of information on here. We've got the various opening times and how long you get charged depending on how long you stay. We have various special circumstances and reduced rates after a certain time and on given days. And we have the general times the car park is open. Looking at this, we can see a number of different situations and permutations that need to be tested for. What happens with half an hour's parking, 1 hour's parking, 1.5 hours? Does it respond correctly to the special circumstances of parking on a Sunday or parking in the evening past 7 p.m? What happens if someone tries to park before 9:30 a.m. or after and parking outside opening hours? Throughout these videos, we've mentioned the importance of the end user. Gaining user feedback at regular points throughout software development is essential. A user should not simply be consulted at the start and then never spoken to again until the product is complete. Regular feedback with the user keeps the project focused, ensures you develop the actual system they need, provides opportunities for discussion, and makes the user feel part of the finished solution. Having watched this video, you should be able to answer the following key question. What are the features of the different ways a program can be tested?